Welcome to 20 Physics. Several electric bulbs designed to be used on 220 volts electric supply line are rated 10 watts. How many lamps can be connected in parallel with each other across the two wires of 220 volt line if the maximum allowable current is 5 ampere? So this is the question they given. First of all, I'm going to draw the diagram for it. So here we are having a power line, supply line. Okay, so two wires will be there. So first one is 220 volts and second one is ground. Okay, like this one will be 0 volts like that, ground. So the potential difference will be 220 volts like that. So he is going to connect the resistors here. You can read here. Several electric bulbs are designed to be used on 220 volts. So here we are designing electric bulbs which can be used on this 220 volts supply line. Okay, and are rated 10 watts. So each electric bulb has power. That power is 10 watts. So here I'm going to draw each electric bulb. So I'm just simply mentioning is a resistor more. So electric bulb resistor here. So the power they given single electric bulb power P1 is equal to 10 watts. And the resistance did they given? No, R1 they didn't given. So simply they gave power. And we also know one thing that these can operate under this voltage. So voltage also we know. So V is equal to 220 volts. So for this bulb we know these things. And resistance we don't know. Okay, several electric bulbs designed to be used on 220 volts. This bulb can be used for which can be used for this 220 volts electric supply and are rated 10 watts. So this bulb has rating 10 watts. How many lamps can be connected in parallel with each other across the two wires of 220 volts? Meaning what? Meaning how many lamps we can connect here across this 220 volts line here? How many lamps we can connect like this? 1, 2, 3 and so on to n. How many you can connect? Understood? How many you can able to connect like this? That is the question they are asking. This is nth one. How many you can able to connect like this? 220 volts line. If maximum allowable current is 5 ampere, this is very important now. The maximum allowable current is 5 amperes. Meaning what? So this total circuit here, so it is drawing current from this power supply line, right? So this from here at the beginning, how much current? This maximum allowable current is 5 ampere. Here I am again saying that. So maximum allowable current to the total circuit, not for only this resistor. That is important here. Okay. So one resistor, maximum allowable current 5 ampere. That is wrong. So this total circuit, how much maximum allowable current is 5 ampere. That is the question they ask. So how to do this problem? Any guesses? Okay. First of all, if you want to do this problem, we need a circuit, like which familiar circuit. Okay, this is not look like a familiar way that we are drawing circuits, right? So I am going to convert this circuit in forms of our familiar circuit knowledge. So here I am going to draw the DC. So this is 220 volts and that's all. And here we are going to have so many resistors. Okay, so this is 1 and this is 2, this is 3 and this is 4, like that so many more, so on to n. This is 5 and I am going to draw so on. So this is so on to n. Okay, like this, so on to n. So n resistors you can draw like this. Okay, so this is 220 volts that we know, and we also know another thing, that is what? Power. So each resistor power we know. So power P1 that is equal to 10 watts. For this also power 10 watts, for this also power 10 watts, for this also power 10 watts, for this also power 10 watts. For all resistors power is 10 watts only. Okay, first of all this problem can be solved in two methods. So first method is very easy method. So what I am going to do is I am going to find out how much current it needed, this bulb for glowing, how much current it needed. That I am going to find out. How we can find out means by using this one. So here power is equal to VI formula, you know, right? So power is 10 watts, voltage we know that is 220 volts, and I we need to find which is current. So current is equal to 10 divided by 220 volts, right? 10 watts divided by 220 volts. Now I is equal to how much will get more here? See, so 10 divided by 220, it is equal to 0. I'm going to write all all value ma. So 0.04545455. So like this, the total value. I'm going to write total value now. So this is the total current which is needed for one bulb. So this bulb needed this much current. 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 Like that, all bulbs needed same current only. Okay. Now, if you remember Kirchhoff laws, Kirchhoff's first law is what? So total current will be divided here, right? So I1, I2, I3, I4, I5, I6, and so on to IN, like that. So it will divide. And again, these all currents will be, again will sum up here. Again will sum up here, and again we'll get I here, total current, right? So what I'm going to do is, if you observe, this I1 is equal to I2 is equal to I3 is equal to I4 is equal to I5 is equal to I6. So means what, say all needed same current only, right? So this is power watt, this is also 10 watt, this is also 10 watt, this is also 10 watts. Indicates that what? This one also needed this current. This resistor also needed this current. This resistor also needed this current. This resistor also needed this current, like that. For all these same currents only. So here we can write that I1 is equal to I2 is equal to I3 is equal to I4 is equal to, and so on to IN. How many resistors are there? That one resistance IN will be there. And if you see here, this is the total current, and the total current itself is going to divide, right? So what is the total current? Already in the question they mentioned total current is 5 amperes. So total current itself is going to divide into this many currents. Okay. So that means what? Total current I is going to divide into I1, I2, I3, and so on. How many resistors are there? That many resistors. So I1 plus I2 plus I3 plus I4 plus I5 and so on to IN. How many are there? We don't know. That's why I kept IN. So total current is what? 5 amperes. That is equal to I1 is what more? I1. Here we can see all are same resistors only. So that means what? Whatever this needed current, the same current this one also will get. The same current also, this one also will get, like that. So current will be divided. Current will be equally divided for all the resistors. So I1 is equal to I2 is equal to same. So I plus I plus I plus I plus I plus and so on to IN. So this one also I only, but n times. Here we are having n times. So how many these i's more? So n i's. N is 1, 2, 3, 4, 4 and so on to n. So Ni. So Ni is equal to 5 amperes. So what is the n? We need to find n. N is equal to 5 amperes divided by I. So what is the I here? For each resistor, what is I? We found that one. 0. Like this. So that one we are going to find. So 5 amperes divided by 0.04545455. And if you see here, this ampere will get cancels, and we need to do division here. Okay, 5 divided by 0.04545454. So if you see here, we will get the answer 110, right? So that is equal to 110. So what is this meaning, ma? What is this meaning means? This 5 amperes is divided into 110 times. Okay, 5 amperes is divided 110 times equally. Okay, so this is one time, second time, third time, fourth time, fifth time, sixth time, seventh time, again 8th, 9th, like that. How many times this 5 ampere divided? 110 times divided. So in each branch, in this branch, how much current is going more? 0.4545455 amperes is going. You understood now? So what is that meaning? We are having how many branches here? 110 branches we are having. So this circuit, at this node, we got sub branches. These branches, how many branches we are having means 110 branches we are having. 110 branches means what? 110 resistors will be there, right? So 110 resistors will be there. Like that we can simply say it. I mean, without doing big calculations, simply we can say that we need 110 resistors, like that. 110 resistors.